Good day. I'm Dr. Jason Myers with Resource Potentials Propriety Limited, located in Perth. I'm a geologist and geophysicist, also with a master's in geochemistry. We're assisting FDR with a lot of their desktop studies and targeting for gold, rare element deposits, and lithium pegmatites. We're pretty excited about the Lander West project because there's already been some historical drilling out there that drilled through the thin sand cover in areas of outcrop and got gold intercepts of, close to a gram per ton in shallow holes, which is indicative that the region is fertile for gold. And we definitely believe that RC drilling below that could intercept a much more higher grade source of gold, at least where there has been wide spaced drill holes. Uh, the company had recently flown a very detailed, high resolution airborne magnetic survey where we collected the magnetic data and processed the data to highlight the subsurface geology and the various structures that could be related to gold and other minerals. In the outcrop areas, we've highlighted faults and thrusts in the aeromagnetics that we couldn't really see on the ground. And those are great conduits for gold bearing fluids. And what I find very exciting is just to the north, within the Lander West tenements that FDR has, is a large granitic baphomet that even the Geological Survey of the Northern Territory hasn't mapped because it's under thin sand cover or thin blanket of sand. It's a very large granitic baphomet, probably has an age of about 1.59 billion years when we look at patterns similar to outcropping granites to the east. These are very fertile granites. They've been fractionated, meaning that a lot of the fluids that are incompatible, like gold, uranium, base metals, accumulating these granites as other minerals will drop out of the melt, leaving this kind of mineral-rich fluid behind, which will then go into the surrounding country rocks. So we're targeting what we call metasediments. They're sedimentary horizons with volcanics that are folded and faulted, slightly older than the granites in the Reynolds Range terrain. And the fact that we can now visualize where the contact of this granite is, and in some cases we can see some circular anomalies, which look like floods or individual plutons. And one of the areas where we're drilling for gold, and we've just completed some induced polarization, where we have anomalies in chargeability, which indicate the presence of sulfide minerals, primarily pyrite, but other minerals such as arsenopyrite, and the fact that arsenic is common in geochemical surveying, that there has to be an arsenic sulfide mineral source. So we're now getting targets in the induced polarization around these granitic plugs that we can see in the magnetics, and also association with gold and other elements such as bismuth and even uranium as just a pathfinder element. So we're getting a bit smarter on what's happening under this thin blanket of sand. We don't have to drill too deep. We can tell from the magnetic anomalies that the sand cover out here is anywhere from 1 meter to about 20 meters. We can use air core drilling to pattern test the area and get some fresh rock sample. But in the areas where there has been wide-spaced historical drilling and there has been anomalous gold, we plan to use reverse circulation drilling. That's reverse circulation to test below these anomalous gold sources. And in the process, we'll also be testing these induced polarization anomalies and some shear structures that host gold, what we call the Stafford trend. And the Stafford trend are these two long gold trends that continue to the southeast and to the neighbor's ground. And the neighboring company had been intersecting high-grade gold, very high-grade antimony integral percentages along the same trend. But we're closer to the heat engine, the large batholith with FDR. And it's a large package of ground, and the geophysics, geochemistry, the mapping that's been done by the FDR geologists on the ground, collecting rocks, looking at properties, we're combining all of this information to be a hell of a lot smarter in terms of targeting zones and de-risking, so we can focus on these areas that we have high confidence will come up with gold mineralization. And while we are identifying these targets in parallel, we're also applying for ground approval, doing environmental studies, heritage studies, so that we can get out there and FDR can start drilling in the short term, especially now that the cooler months are coming and the wet season it's finishing up.
Hi, my name is John Sinnott, and I'm a geophysicist with Resource Potentials. I've been in the industry for about 20 years, and about 16 of that with Resource Potentials here in Perth, Australia. And so I've been working on the Selta project. At First Development Resources have the Selta project located in the Northern Territory. And it's quite a big project area. It's right on the edge of the Nalia Basin and located over Proterozoic greenstone belts. And historically, this area has been explored for uranium associated with the Nalia Basin in the sediments. But the area is also very, very prospective for gold, copper, antimony, as well as lithium, cesium, and tantalum with pegmatite, and also rare earth elements that are such as the etched Nolan 4 located 100 kilometers to the southeast. So this is a big area. There's a lot of data to go through, but today we're going to be mainly talking about the Langer West prospect, which is in the western part of Selta, and that is more of a gold, copper, antimony project. And so the first thing that we did was to compile all of the historic data that's available over here. And that includes magnetics, radiometrics, airborne electromagnetics, digital elevation model, surface geochemistry, and drilling. And so Resource Potentials compiled all of these different data sets. We applied filters to them, made a suite of images of each of the data sets, brought them into GIS, and basically went through all of these to try to come up with a story of what to do next. And so the magnetic data were very useful in terms of mapping out some of these major features, such as the Reynolds Range shear zone, and adjacent to that is the Stafford Gold Trend. And this extends through the Langer West project within FDR tenements for about 20 kilometers of strike length. But it was pretty wide-spaced data, so you can't see the very subtle features that are oftentimes very important for gold mineralization. We also have airborne radiometric data, and these are very, very useful for identifying potassium, thorium, and uranium anomalies. Now, potassium anomalies can be very important for gold exploration because they can tell us zones of potassic alteration, which is often associated with gold. But outside of the gold, potassium anomalies can also indicate LCT pegmatites on surface, and uranium and thorium anomalies are often associated with rare earth element deposits, such as at Nolan's or along trend to the south. And so all of these data sets are very important, but for the gold exploration, it's mostly the potassium. So one of the downsides of radiometrics is it's only effective in areas of outcrop or subcrop. And as soon as you have sand cover, transported sand, then it's not effective. And so we compiled digital elevation data, and using this, you can see where the outcrop and the subcrop zones are. And the areas that are perfectly flat are just blankets of sand, and it's ineffective there. Where we do have the hills of subcrop and outcrop, that's where the historical geochemistry was applied. And so we took the samples, the historic samples, and plotted those in GIS for all of the available elements. And we noticed very obvious anomalies in gold, copper, silver, and indicator minerals such as bismuth and arsenic. So we started getting excited about this one area of outcrop and subcrop at Langer West. We also looked at the drilling data. And at first glance, you look at Langer West and there's quite a lot of historical drilling. But the vast majority of these drill holes were shallow and were only looking for uranium. So they did not drill down to the bedrock, and they were only assayed for uranium and not of the the other elements that are needed for gold exploration. And so once we removed those ineffective drill holes, then there were not very many. They were mostly over the areas of subcrop and outcrop. And similarly to the geochemical samples, these were anomalous in gold, silver, copper, arsenic. And so we decided with FDR to acquire more magnetic and radiometric data to get higher resolution data sets over this area. And we flew using Thomson airborne geophysics. We flew a 50-meter spaced airborne magnetic survey, and the data are fantastic compared to the historical data, where we can see a lot more subtle structures. Some of them may be very critical for the gold mineralization. Gold is not always in the biggest and most obvious structures. They're often in small splays coming out of the zone. And so we processed the data, we applied our geophysical filters, and we made a new suite of magnetic and radiometric images. Using that, we reinterpreted the extension of the Stafford gold trend through FDR tenements, and then found an area which we considered the most prospective area for ground-based gradient array-induced polarization surveying. And this is going to cover an area of 12 square kilometers where they are acquiring chargeability and electrical resistivity data. And the usefulness of these data sets, resistivity or conductivity, can tell us areas of thicker cover and sediment, which we're not interested in, or areas with bedrock, and specifically in areas of bedrock, resistive zones that may have been silicified, like a quartz vein. Also with the data are chargeability. And so chargeability, when we inject current into the ground and survey in that current, things in the ions in the ground line up, and then they go back to their resting state when the current is turned off, kind of like an MRI machine, but for the ground. And what this tells us, this can find areas of clay, which we're not interested in. That should also be conductive, but it can also find areas of disseminated sulfides, such as pyrite and chalcopyrite. And so when we get a chargeability anomaly that is associated with a resistivity anomaly, that tells us that it could be a quartz vein with disseminated sulfide in it, and this would be a good gold target. Now, that coincides with a structure that we can see in the magnetics, and along that structure, we've got a geochem sample with anomalous gold in it. That becomes a very high priority target that we're interested in for follow-up. So that is an ongoing process, and that's where we're at right now, is that we're compiling these different data sets, all of the different layers of information to try to identify the best targets, get a suite of prioritized targets, which we may go out and do more geochemistry on to refine, or we'll test them with a drill rig soon. And so it's a very exciting time. It's finally coming all together, and we've got a great suite of targets, and I'm very excited to see what's going to come out. So I'm very excited personally about this area. We have worked in the Arunta from one end of Western Australia all the way to the Northern Territory. We've been involved with a world-class discovery of carbonatite for one of our clients. We have a number of clients in the region for multi-commodities. And I personally believe that the ground that FDR has in this part of the minerals range is got excellent potential. And now they're focusing directly on this as their priority, along with their other project in their well project in Western Australia. But right now the focus is on Selta. And we're putting all of our efforts into this. We're going to get out very shortly. And fingers crossed, but I'm confident that we'll be getting gold, and we'll be working out and understanding the mineralizing system, and hopefully a major gold discovery this year if all goes well.